Hello, welcome to my channel. We will be doing this. We will solving this previous exam. You can see it is from May 2000 to 2025, and it is mathematics, mechanics. Okay, so let us start. This is the question number one first. Okay, so what does this question say? It's talking about the momentum, conservation of momentum. Okay, there are two particles P and Q of masses 0.1 kg and 0.3 kg respectively are at rest on a smooth surface. Okay, so there was a smooth horizontal surface and there are two objects. One is P, one is Q. So let me write this is P and this is Q. The mass of P was 0.1 kg and the mass of Q is 0.3 kg. Okay, and their P is projected directly towards Q with a speed of 4u. So the speed of this one was 4u meters per second. Okay, at the same time, the Q was projected towards P, and the speed of Q was u meters per second. Okay, now what will happen? Of course, they'll collide with each other, right? So they will collide with each other, and as a result, they will move again. Now, uh, so okay, after P and collide, P moves with speed this one, and Q moves away with this speed. Okay, but there's a catch here. They are not telling us the direction of this movement. Okay, so let's assume this is lighter one, but it has heavy speed 4 times. This is heavier, but has lighter speed. So I will assume that this is Q and this was P. I will assume that Q was moving in this direction after the collision. Okay, and P moves at this speed and Q moves at this speed of, and the speed of Q is 4 meter per second. Okay, and the P moves, so P could be moving in this direction or in this direction, right? So we do not know the direction, but the speed of P, it is given as 2 meter per second. Okay, P moves with speed 2 meter per second and Q moves with speed 4 meter per second. Okay, find the two possible values of U. Okay, so I will apply the law of conservation of momentum. So initial momentum or the momentum before the collision is equal to the momentum after the collision, right? So what's the total momentum before the collision? You see, has positive momentum. Remember, momentum is a vector quantity, so we have to consider what its direction as well. So this is when the positive x direction, I will assume which momentum is positive. So this momentum is 4u, this is the speed, time its mass 0.1 kg minus the momentum of this guy is u into 0.3, right? Now this momentum must be equal to momentum after the collision, right? Okay, so after the collision, this guy q, it is moving in the positive direction, so its momentum is 0.3 times 4 meter per second. Okay, and the P is moving either plus direction or minus direction. So I will assume that it is either positive or negative. We don't know yet, right? Its mass is 0.1 and its speed is 2 meter per second. Okay, so we can solve this equation and find the value of U. You can say this is 0.4 U minus 0.3 U equals, this is 1.2 plus minus 0.2. So 0.4u minus 0.3u will become 0.1u, and this is equal to 1.2 plus minus, so this is equal to either it is, if I subtract, it is 1, and if I add them together, it is 1.4. So U would be equal to, if I multiply by 10, it is going to be 10 or 14 meters per second. So we will find the two possible values of U. So we found these two other possible values of U. Okay, I hope it's clear. Now find the largest possible loss of kinetic energy in the collision. Okay, so let's find out the uh, kinetic energy initially in the before the collision. Okay, kinetic energy is 1 by 2 mv square. So what's the total kinetic energy? 1 by 2 mass of this object P was zero point 0.1. Okay, 0.1. Okay, now one question, sorry. You see, kinetic energy depends upon the speed. And speed, we have two values, 10 and 14. So let's do these two different calculations. So I'm doing it if u is 10. Okay, then the initial kinetic energy is going to be 1 by 2 uh, half m and v squared. The velocity of P was 4u. 4u means 40, right? U is 10, so 4u is 40. So we will do 40 square here into 40 square, right? Plus half, and the mass is zero point 0.3, and the speed was only u, which is 10. So it is going to be 10 square, right? Okay, if I do all this math, 40, so it comes out to be 95. Okay, and if u is considered to be 14, okay, then the kinetic energy initial would be I mean half and zero point 0.1, and then not 40, 40, now 4 times 14 is 56, right? So it is 56 square plus 1 by 2, 0.3, and 14 square. And this all comes out to be 186.2. And of course, the units are joules for both of them. Okay. And what is the kinetic energy at the end? So after the collision, I will write it as kinetic energy final after the collision. So for okay, now the kinetic energy does not depend upon direction, right? So it is the same. We know the speed, so we can calculate the kinetic energy. It is going to be half, and mass is 0.1, 0.1, and speed is 2. So this is 2 squared plus half, and mass is 0.3, and speed is 4, 4 squared, right? So this comes out to be 2.6. Okay, so you can see that the energy loss was huge. This is the final energy was after the collision is 2.6 joule only. So initial energy, it was either 95 joule or 186.2 joule, depending upon what is the speed of the U. Okay, so the energy loss you can calculate by subtracting these values. So what was the question again? Find the largest possible loss of kinetic energy. So for the largest loss, I will use this large value. Okay, so energy loss is 186.2 minus 2.6. So how much is this? 186.2 minus 2.6. So it comes out to be 183. 183.6. Okay, I hope you understand everything. We need to understand the logic of this problem. Okay, in all of these problems, you just have to design a strategy, design the logic. What, how are you going to do? Okay, question number two. Okay, question number two. I will wait only one part. Okay, this is interesting. The scenario is that on a flat road, there's a van going on, and van is pulling a tractor. Okay, the mass of the van is 4,500 kilograms, and mass of this trailer is 350 kilograms. Okay, uh, this is a tension T Newton in this rod. Okay, there is a friction force, and that is 120 Newton for the case of trailer, and X Newton for the van. Okay, the engine of the van is producing a force of 2,500 Newton. Okay, and the whole assembly has an acceleration of 0.4 meter per second square. So we need to calculate the tension and this resistance force on the van. Okay, so let's analyze this problem. Well, I need the free body diagram for this trailer first. So this is my trailer. This tension in the rod is T, which is pulling it basically. Okay, and the frictional force, which is 120 Newton. And the mass of this trailer, it is 350 kg. Okay. Okay. So what's the net force on this? And of course, the acceleration of this whole assembly is 0.4 meters per second square. Okay. So what is the net force on this trailer? There is force of T which is pulling it. There is a force of 120 Newton which is resisting it. So this is the net force on the trailer. And this net force is equal to the mass times acceleration. Mass of the trailer is 350 kilogram and its acceleration is 0.4 meter per second square. Okay, I hope this is all clear. So from here you can see that this T is equal to 350 times 0.4 and plus 120. And this all comes back to be uh, this all comes out to be 260. Okay, am I right? 260 Newton. Uh, 350 times 0.4 and plus 120. Yes, 260 Newton. Okay. Now let's make a free body diagram for the van. Okay. So this is my van. It has a weight of 4,500 kilograms and the engine is producing a force of 4,005, sorry, give me a second, sorry. Okay, the force of this engine is 2,500 newtons and there is a resistive force of X Newton. And the acceleration of this whole assembly is 0.4 meter per second square. Okay, so let's apply the forces here. The pulling force is 2,500 Newton minus this. Okay, then yeah, sorry. This tension in this rod T, this is also pulling the van in this direction. Remember? So the tension in this rod is also a force here. So 2500 minus x minus t. Okay, this is the net force, and this force is equal to mass time acceleration. Mass is 4500 kilogram, and acceleration is zero point 0.4. Okay, I hope you understand how do I make this equation? This equation. This is the most important thing in this problem. Okay, you have to make the free body diagram for both objects. Okay, so for this van, for example, let me explain it again. The van is being pulled by the engine, and the force of the engine is 2500 Newton, and there was a resistive force, we call it X, right? And there was a tension in this rod. Because of this tension, this trailer is trying to pull it back. So we have to consider that force as well. That force is T. Okay, so the net force on this van is the force of engine minus this resistive force and minus this tension. And this whole thing is equal to this mass and acceleration. Okay, if you understand the logic of these equations, then yeah, everything is very easy. When you can see that x is equal to 2500 minus t and minus 4500 times zero point 0.4. Okay, and we know the value of t is how to define? Yeah, 260. So 2500 minus 260 minus 4500 times zero point 0.4, and this all comes out to be 440 Newton. 440 Newton. Okay, so this is our solution. We will also find x and t, so we found the values of x and t. Okay, hope you enjoyed this solution. We try to understand them. If you ever have any question, you can always ask me in the comment section. Thank you very much for watching. See you in the next video.